Welcome physics students. In today's video we'll be looking at the equations of constant acceleration, which is studied in middle secondary school or senior secondary school. The content of today's video will focus on some fundamentals of setting up and solving equations of constant acceleration. So a quick recap. The equations of constant acceleration consist or use the following variables. We're given an initial velocity, a final velocity, a displacement, an acceleration, or we could be given time. They're the 5 possible variables that can be used in the equations of constant acceleration. The equations we have are as follows. V equals u plus at, s equals ut plus a half at squared, s equals vt, take a half at squared, s equals a half u plus v in brackets t, and v squared equals u squared plus 2as. As the name suggests, these equations are equations of constant acceleration. They can only be used when an object is undergoing constant acceleration. So we cannot use these equations, for example, for a vehicle that travels forward, then speeds up, then slows down, then stops, then reverses. These equations can only be used for constant acceleration. They're commonly referred to as the Suvat equations because they use the letters S, U, V, A, and T. If you look at these equations carefully, you'll notice that each consists of 4 variables, and they differ by 1 variable each. So our first equation, V equals u plus at, contains the vu, a, and t, and is missing the s. Our second equation, s equals ut plus a half at squared, contains the su, a, and t, and is missing the v. And so forth all the way down to our fifth equation. So when you apply the Suvat equations, you should never ask, which one do I use? Because there's only ever one that can be used in a given situation. So typically, you'll be given 3 variables and asked to calculate a 4th variable. Now the steps we should follow, first of all, write down or state the variables. Number 2, select one of these 5 equations. Number 3, substitute in our values and solve. So let's go. Equation number 1. A stationary train departs the station and accelerates at a rate of 4 meters per second squared for 10 seconds. What final velocity does the train reach after 10 seconds of acceleration? So we have our very fast train here. It accelerates off to the end of its journey. Let's have a look. First of all, step number 1, state the variables. I've listed our variables u, v, s, a, and t as blank, so let's fill them in. A stationary train that has an initial speed or initial velocity of 0. It says what is the final velocity, so v equals question mark, that's what we're trying to solve. In the question, there is no information about the displacement or indeed distance. Remembering that if an object is accelerating in the one direction, then distance and displacement are almost interchangeable. So displacement's not given in this description. Acceleration is given at 4 meters per second, and time is given at 10 seconds. So we have a u, a, and a t, and we're asked to calculate the v. So which equation are we using? If we look carefully, we'll see that we haven't got an s. So we can't use an equation containing s. So equation 2's got an s, 3's got an s, 4's got an s, 5's got an s. The only equation that has no s is our first one, v equals u plus at, and that uses the variables that we have. So we'll choose that particular equation. So all we have to do now is write that equation down and substitute in the correct values. So v was our unknown, so we leave that as written as the letter v, u was 0, a was 4, and t was 10. So 0 plus 4 times 10 gives us a final speed of 40 meters per second. Example number 2, the same scenario, except in this scenario we're asked how far does the train travel during the 10 seconds of acceleration. Let's write down our variables again. Our initial speed, it was stationary, 0 meters per second. Final speed, whilst we calculated it in question 1, I prefer students don't reuse that information in a following on question unless absolutely necessary, in case they've made a mistake in the first stage. So the description says how far does the train travel, that's our displacement. Acceleration was given as 4 meters per second, and the time we've been given is 10 seconds. Let's select our equation. So this time we are looking for an equation that does not have v in it. So which one of these equations does not contain v? If we look at it, it's this second one, s equals ut plus a half at squared. So now we choose that equation and we substitute our values in. U was 0, a was 4, t was 10. So a half of 4 is 2, times 10 squared is 100. 2 lots of 100 gives us 200 meters as our displacement. Example number 3. A V8 supercar is initially traveling with a velocity of 5 meters per second. It accelerates for a period of 10 seconds, reaching a final velocity of 25 meters per second. There it goes. What distance did the V8 supercar travel during the 10-second period? So let's write down our variables. In the question, we have an initial velocity of 5 meters per second. We have a final at the end of our situation of 25 meters per second. Our displacement is what we're being asked to solve. What is the displacement? A, in this description, there's no value for acceleration given. And finally, we have a time of 10 seconds. We have to select an equation that uses a u, v, s, and a t. So one of these equations has no a. Here we have it, s equals a half u plus v times t. Now we simply need to substitute in our values to calculate the s. So we're looking for u and v and t, which we have available from our list of stated variables. Let's sub them in. S, our unknown, equals a half times, in brackets, 5 the initial velocity plus 25 the final velocity, close brackets, multiplied by a time of 10 seconds. And that gives us an answer of 150 meters. Example number 4. A stationary turtle turns on her jet propulsion system and accelerates at a rate of 20 meters per second, covering 250 meters. What's the final velocity reached by the turtle? So off goes the turtle with a jetpack. Let's state our variables. Initially, it's stationary, so there's 0 meters per second velocity. Final velocity is what we're being asked to calculate, v equals question mark. Displacement we're given is 250 meters in the question. And we're told that the acceleration occurs at a rate of 20 meters per second. No time is given in this particular question. So we've got a u, s, a, and we want to find v. We turn to our list of equations. Can you pick the right one? Again, we're looking for the one that doesn't have a t in it. So if I have a look at these, I go down, there's a t in the first one, second one, third one, fourth one. Our final equation, v squared equals u squared plus 2as, has no t. That's the one we'll select. Final step, let's substitute our values into this equation. We want the v, so that remains in the equation as v squared. U is substituted in for 0. 2 times a is substituted for 20, and s is substituted for 250. When we do our calculation, that gives us a value of v squared equals 10,000. Now, this is not our final answer. We want to know what is the final velocity. The answer we have here gives us the value for v squared. So to find v, we must take the square root of 10,000, which gives us a more realistic velocity of 100 meters per second. Example number 5. A coin is thrown off the top of a high-rise building with an unknown velocity. It takes 5 seconds for the coin to reach a velocity of 50 meters per second. Here again, there's a start and an ending to our story, our situation. It starts with an unknown velocity and takes 5 seconds for the coin to reach a velocity of 50 meters per second. That's the closing part of our story. That's a final velocity of 50 meters per second. What distance has a coin fallen when it reaches a velocity of 50 meters per second? And we're asked here to take the acceleration of gravity to be 10 meters per second. There goes our coin. The variables we have. U is not given. Here it says it's an unknown velocity. Final velocity is 50 meters per second. That's the end of our description. The displacement is what we're trying to calculate. What distance has the coin fallen? Acceleration due to gravity is 10 meters per second, downwards in the same direction as the falling coin. And the time we have is 5 seconds. This question illustrates a good example. If an object is falling downwards, that doesn't necessarily mean it has to be a negative velocity. I would suggest to all students, whatever the direction of the initial velocity, consider that direction positive. So if we take the coin falling downwards towards the earth as positive, that means our v is positive, our u would be positive, our s would be positive, and our acceleration due to gravity, a, would be positive. It just makes the calculation so much easier. Step 2, select the correct equation. So again, we can see here that u is not given in this particular description. So we need to find an equation that hasn't got a u in it. Top equation has a u, so it's the third one. S equals vt, take a half at squared. There is no u in that equation. So we'll select that. Substitute in our values. S equals vt, take a half at squared. So v was 50 and t was 5. A was 10, which gives us a displacement of 125 meters. Example 6. A stationary rocket sits on the launch pad. Upon launch, it is accelerated at a rate of 20 meters per second for a duration of 30 seconds. What speed does the rocket reach after 30 seconds of acceleration? Again, an initial velocity of 0, it's stationary. We don't know its final velocity, that's what we're trying to calculate. The displacement is not given anywhere in the question, that's not given to us. Acceleration is stated as 20 meters per second, and the time taken for this period of acceleration is 30 seconds. Here's our equations. We need to select an equation that's missing s. Right at the top, v equals u plus at. So we choose that equation and we sub our values in. U was 0, a was 20 meters per second, and t was 30. So that gives us a final velocity after 30 seconds of acceleration of 600 meters per second. Example number 7. Same scenario, a stationary rocket sits on the launch pad. Upon launch, it accelerates at a rate of 20 meters per second for a duration of 30 seconds. This time we're asked, what distance does the rocket travel during the 30 seconds of acceleration? Number 1, let's state our variables. Stationary rocket, an initial velocity of 0. Final velocity, whilst we calculated in the previous question, we don't want to use it again in this one unless it's our last resort. S is our question mark. What is the distance? Distance and displacement will be the same magnitude with constant acceleration. The acceleration was 20 meters per second, and the time for this particular acceleration, or the duration of this acceleration, was 30 seconds. Select the equation. Again, we have everything except for the value for v. So we need to find an equation that hasn't got v in it. And we can see that our second equation, s equals ut plus a half at squared, has no v. So we'll choose that one. Let's substitute in our values and solve. S equals ut plus a half at squared. U was 0, t was 30, a was 20. We sub our numbers in, and we get a displacement or a distance of 9,000 meters or 9 kilometers. The last couple of examples, let's have a look. This is slightly different. Tennis ball is hit straight up with an initial velocity of 50 meters per second. What maximum height above the racket does the ball reach? In this case, we've been asked to take the acceleration due to gravity as 10 meters per second downwards. So the ball is leaving the racket at a speed of 50 meters per second and being decelerated due to gravity all the way up to the top where it finally reaches a final velocity of 0. Let's write down our variables. So the initial velocity was 50 meters per second. You'd recall earlier I suggested that let's just take whatever direction the initial velocity is as a positive direction. So in this case, I'm suggesting let's use the initial velocity moving upwards as our positive direction. So up is positive. Final velocity is 0. Right at the top, we have a velocity of 0 meters per second at the top of the ball's trajectory. Displacement, the maximum height, that's what we're trying to calculate. Acceleration is 10 meters per second downwards. It's going in the opposite direction to the initial motion. So accordingly, we write down acceleration as negative 10 meters per second. Gravity is working against our motion and is effectively decelerating the ball. We have not been given the time for this particular motion description. Step 2, select the equation. We're looking for the equation that does not contain a t, and there's only one of those, and that is v squared equals u squared plus 2as. We select that equation, and we simply substitute in our values. V squared equals u squared plus 2as. We sub them in, leaving s as our unknown, so v is 0, u is 50, a is negative 10. Important that we keep our acceleration as a negative 10 in this equation. That results in 0 equals 2,500, take 20s. We'll now move our 20s to the left-hand side by effectively adding 20s to both sides of the equation. That gives us 20s equals 2,500. To get s by itself, we divide both sides by 20. That leaves us with s equals 2,500 divided by 20, a final answer of 125 meters. The final part to this video. Tennis ball is hit straight up with an initial velocity of 50 meters per second. How long does it take for the tennis ball to reach its maximum height above the racket? Take acceleration due to gravity as 10 meters per second downwards. This is the same type of scenario as previously, only now we're trying to work out how long it takes for the tennis ball to reach its maximum height. So again, step 1, let's state our variables. Initially, there's an upwards velocity. We're going to take that as a positive direction of 50 meters per second. Final velocity at the top of 0 meters per second. S, the displacement is not given. We're not going to use the previous value. We're going to continue on and try and solve from the variables that we'd have in case we made a mistake in the previous question. The acceleration we've been told is 10 meters per second downwards. All our other measurements are being taken as positive as upwards. Acceleration is downwards, so it's negative 10 meters per second. Finally, we want to find out t, the unknown. Let's select our equation. We're looking for an equation that does not include s. You can see the very first equation, v equals u plus at, hasn't got an s. It's the only equation that had an s. So we're choosing that particular equation. We simply substitute our values in and we solve for t. So the value 0 is substituted for v, the value of 50 is substituted for u, and the value of negative 10 is substituted in for a. That gives us an equation of 0 equals 50, take 10t. We'll add 10t to the left-hand side of our equation and now divide both sides by 10 to get an answer for t. T equals 50 over 10, which equals 5 seconds. You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.